So one of the things that I like the most about mathematics is how we can use it to make sound. In the question that we're looking at in this web work, we're asked to find the derivative of something that is a function based on what's called frequency modulation synthesis. And so I was hoping I could say a bit more about that. So first, I know we're all hoping to get the green check mark, so we'll copy, say derivative of that, and hopefully WolframAlhpha can read it, and it cannot, so I'm going to have to type the function in. WolframAlhpha gives me the answer, so then I want to copy paste this and put it back into my web work, and hopefully yep, awesome. So that's done, and now we can talk about frequency modulation synthesis. Frequency modulation synthesis is a way that complex signals can be produced. Basically, you're putting one signal on top of another signal. This is something that the engineers who originally built synthesizers for electronic music had to think about. So if I look at this kind of thing, I can go to WolframAlhpha, I can say play, give it a formula, compute the input, and it gives me a waveform. And when I click on that, I can do play sound. Now that one doesn't do much, the frequencies aren't high enough. But we could look at this instead as being a parameterized family where we have A and B, and these are parameters. So let's look at maybe 100 and 300. Play that. It gives me the waveform, and now I can play that sound. That's still not very interesting. Let me see if maybe 500. There's a lot of wobble there. Let's see, 500. Now that makes a sound that's kind of interesting. So that's what's called frequency modulation. If you look back at like very early 1970 synthesizers, they were using this to get their sounds that they were looking for. And what you could do to make more complex sounds is you could combine more than one of these. And I'm just totally randomly guessing, but engineers actually have a process for how they do this. So you can get things that sound kind of fun. And I wish there was a way to combine this with Desmos. If you take my Introduction to Scientific Computing class, we actually do this. We actually try to make a drum sound. The way you make a drum sound is you can have some level of decay. So let's first start by sounding what is the low frequency. So let's bump it up to sine of 1000x. There we go. And now what I want is I want something that sounds like a drum. So to make that happen, I'm going to make this decay. And if I do an exponential function that has a negative variable in it, we think about what the graph of e to the 3x, negative 3x looks like. It's got this rapid decay. So if I take a wave and I multiply it by that, this rapidly decaying sound. It turns out this is really useful to make it like a primitive drum sound. So if I hit equals, hit play sound. If you put this in and you turn the sound up, you get like a very crude kick drum sound. And if you play with the different parameters, you might see how you can adjust it, maybe make the bass a little lower, maybe make the decay a little bit faster. It's actually a decent drum sound, but I'm gonna play with it a little bit more. Very synthetic sounding with those parameters. So this is how some early electronic music things were actually produced. And I think it's really cool that calculus contributed to this.